There we go.
Like pretty much everybody's here except for two people.
I guess everybody who's coming, I guess, is here.
The other two are coming, but they're, I'm guessing, a little late.
Delayed?
For what?
Okay.
One of them's usually late, so that's normal. But
Right. So we do have the new magic hand, but can anyone be in charge of keeping an eye on the Calgary channel for me? Just help me out there. I had to turn that like text to speech off. That was was driving me crazy.
especially if you forget it's there.
Mm-hmm. Um, okay, cool. So I'd like to confirm that Calgary can hear me okay before I start talking a bunch. Is that is that a thing? Sound is a bit low. Okay. Um, Try turning it up a little bit. How's that? Okay, good. Good, good, good. All right, so let's get started. Today we're talking about errors a little bit and promises a lot. So we're mostly talking about promises, and hopefully it'll become clear in a little bit why errors kind of play into it. But just to get a feel for where everybody's at, how much work have we done with promises so far?
We know what they are.
Just barely? Okay. Have you worked with them yet at all?
Yeah, like some of us used it, but don't really understand.
Some of you have used them. Okay. What sort of things have you used them for?
Chain, lemon, catch.
Okay. Chaining stuff, then catch. There's a finally in there. Oh. Some people were told not to use them. Interesting. We've used connects before, right? And connects has a callback interface, and it also has a promise interface. And in the case of connects, it's really like it has a promise interface, but it lets you pass callbacks to the connects function instead. So it gives you methods like as callback. But they're really doing the same thing. It's this concept of inversion of control, where you're handing off some code, you're writing some code, and the intent of that code is not to say, I want this to run right now. The intent is to describe a behavior that you want to happen at some point. And when that point is determined by some other piece of software. So in the case of connects, it's when your Postgres database decides that it's time to run the function, usually when it's finished a query, then it runs that code. Getting a little ahead of ourselves though. Let's talk about errors first. So in imperative programming, you might end up with code that just looks like this. You're just going like line by line. Yes. I think. Is that good? Even more. How about in the back? Is it okay in the back? Okay, cool. Cool. And I do want to I'll make this bigger too. So I think this is in, yeah. Cool. So we get infinity. Why when I run this script do I get infinity? Does everybody see what happened there? Just out of curiosity, unrelated to promises or errors. Yeah, it's because I divide by 0. Yeah. So that's kind of confusing. I'm actually just going to take that out for now. Um, Basically, we're doing these like step-by-step operations. This is what we would refer to as imperative programming or procedural programming. All we're doing is we're writing the lines of a procedure that are going to be followed more or less in sequence, run one at a time, and you can depend on number down here is going to have a value related to what happened up here. It's kind of the standard way we learn to program, right? It goes in reading order, left to right, top to bottom. Um, and each one of these operations runs as like a discrete thing. So when something goes wrong, um, it gives us a way to zoom in on specifically which thing went wrong. So all of these operations are valid operations. The addition operation, the multiplication operation, subtraction operation, those are all valid things to do to a number, right? What do we expect to happen if I go digit? What's going to happen here? Let's make that a map. It's wrong, but it's a different kind of wrong. On the right side? Pull that out a little bit. What happens when you call dot map on on a number? Well, dot map is used for iterating through an array or an enumerable, and you go item by item and do something to it, right? So I go back into my node console, and I go, 5.map. And it doesn't really matter what function I pass to it here. Oops. It gets very confused, right? Whereas if I just instantiate an empty array, we get a different kind of error, or we don't get an error. We just get an empty array back, right? Um, so we do get an error. I guess the syntax error happens for a different reason. This is the error that I wanted to bring up. What does this tell us? That map can't be used on the number because the number is just an integer. Yeah, that's more or less correct. I'll make the distinction that map is a method on map is not a function, it's a method. So that means that whatever the number is kind of brings all this, or whatever is stored in this variable brings all of this stuff along with it. Like when you call .map or when you call .to uppercase on a string or something like that, right? Those are methods that value brings along with it. So what this error is saying is number.map is not a function. In other words, whatever value is in here, it doesn't bring .map with it, right? And we get a type error, right? So there are a few pieces of information here. One is this is the type of error. It's a type error. So up here we got a syntax error. That means this isn't a valid way to write JavaScript. And we get a type error, which is to say that the type of this value doesn't match up with the thing that you're trying to do with it, right? So our errors give us a bunch of information like that. And good errors are quite clear about what's going on. So if we run it in node script, we get a little more information, right? So we still get our type error. Oops. Number.map is not a function. And then we get all of this other stuff. And what's this stuff? Any ideas? It's a little esoteric. I didn't write any of this. What's going on in here? It's telling you where it's breaking, yeah. Yeah. So this is actually a bunch of node stuff, which isn't like our responsibility, but if we go, don't name your functions like this. If we do something like that, if we wrap it in a function, as most of our JavaScript ends up being, we see that appear. We see that appear here in the stack trace. So properties of a good error are they tell us where something went wrong, they tell us what went wrong, and they give us an idea of which values were involved. So here we have number and we have .map, and both of those appear in the error. So we know that something went wrong here. And we know it's a type error. There's something wrong with the type of the value that we passed along. So I'm going to show you a pattern for handling errors. So it's a try-catch pattern. Anytime you have a bit of problematic code, or code that is potentially problematic, sometimes this isn't in your control. Sometimes you have you're using some library that fails for reasons that you don't totally understand, and you can pass it all the right things, and maybe it still fails. You might have bits of brittle code that you depend on but can't necessarily rely on. So when you get an error, you don't just want your app to explode. You want something to handle it. So that's why when we talk about errors, we tend to talk about error handling. And the pattern that we use for that in JavaScript most commonly is try-catch. So the syntax for try-catch is very simple. So if we just look at the shape of that, does that look familiar at all? Does that look like anything else that we're used to using? What does it look like? Yeah, it looks like if else. Like Java? Interesting. Yeah, it's kind of the same shape as if else, right? And in a way it does the same sort of thing. It looks like an object. Interesting. It looks like an object. Let's come back to that. So it's kind of the same shape as if else, and in a way it's doing the same thing. So if else is for flow control, right? So in an if statement you pass it a predicate, something that evaluates to true or false. And then depending on what's in the predicate, it decides whether this block runs or whether this block runs, right? Try-catch works in sort of the same way, but instead of passing it a predicate, try-catch is looking for an error. So when an error triggers, it kind of starts floating up the stack, right? So like this function calls this function, calls this function, calls this function. An error occurs here, and it passes it up to its parent, and it says, hey, there was an error, what do you want to do about it? And if that parent doesn't handle it, it says, hey, there was an error, what do you want to do about it? And then if that parent doesn't handle it, it keeps going and going and going until it gets to the top level, and then node just goes like, oh, and crashes. Um, what try catch does is it intercepts that. It notices an error bubbling up, and it says, oh, I know what to do about that. So it stops doing what it's doing in the try block, and starts doing what it says in the catch block. And it gives you access to the error, kind of the same way a function parameter works. So if we have this problematic code, we can put it in this try catch block. And what do you suppose might go here? Any ideas?
Console log error.
Console log error? That seemed to do the thing, right? There's the error in the console. What's interesting though is if we go, so you put that at the end just to like, just so we know that the script kept running. Here we see the script kept going after the crash. Do that kind of in a backwards way. Here it doesn't. So do we see the difference there? Here we're just doing that like normal imperative programming plan, right? Where first we're gonna do stuff, and then at the end we're gonna console log. We're gonna console log this to say we finished, right? So I'll do that again. So when we don't handle the error, when we don't catch it, we don't see this last line run. We don't see those stars appear in the console, right? Whereas when we do our try catch thing, we see the error appear, so we're aware of it, but the script doesn't stop. We've handled it, right? So that becomes really important. Generally, when you're developing code, when you're developing software, you want things to fail loudly and fail early, and you want to be very aware that something is wrong. And as soon as anything's just a little bit wrong, the app should blow up and put a red screen in front of you and tell you, you did something wrong on this line and here's what. And then you go away and fix it. But when you deploy that code to the public and you have customers using it and people depending on it, you don't want it to blow up in the same way. Does that make sense? Things can go wrong, but you want the application to have a plan for recovery. And that's what catch is. When an error comes bubbling up, the catch block says, I know what to do about that. Maybe what you do is you reset a value. Maybe what you do is you terminate a request, right? Maybe what you do is you tell the user to redirect somewhere else. Maybe all you do is you log the error and just keep going. You say, oh, that's a bad thing that happened. Don't crash, though. So any questions so far? That's pretty much all we're going to say about try catch. What's the difference between console log error and console error? Good question. Let's see what happens if... So we've changed that from console log to console error. Let's see the difference. Oh, do you see the difference? No, I don't think there is a difference in Node. But if we do something if we do it in my browser here, let's maybe make it a separate window. So it looks different. And in addition, when we open it, we get a stack trace. Now I did this right at the top level in the console, so it's a very, very short stack trace. But in the same way that in Node we got, it happened in here, and this is the thing that called that, and this is the thing that called that, and this is the thing that called that. We get this stack trace. With console error in the browser, we get the stack trace. So not only does it look visually like an error, but it also does some stuff for free that we want when we get an error. Whereas with a console log, we kind of just want the text in the console. Does that help? Yeah. Cool. Cool. So who wants to learn how to make our own errors? Good. One of you. Everybody else is like, why do I want to do that? I get enough errors. Why do I want more? I appreciate that. So throwing a custom error can be as simple as just, asking for a new error. Is that as big as that goes? Can anybody see that? Can anybody not see that? It's kind of too tiny. Okay, we won't do that then. Oh wait, maybe I can. Yeah. Bad error message, right? What's wrong with this error message? It's vague. Yeah. It's vague. It doesn't tell us where the error happened. It doesn't tell us what values were involved. And it doesn't tell us anything about what went wrong. So yes, vague, but just to break it down a little more, those are the three things we look for. So creating a new error is basically as simple as that. It just says error. This is just a generic error. And then we get a message. And then we get our stack trace. And that's pretty cool. So I guess I said I was done talking about try catch, but one thing that I will say about try catch in addition is that one of the things that you want to do in your catch block is you decide, is this an error I can recover from, or is this an error where I should really just blow up, right? So you might say, so you might say something like this. You often care about what type of error it is. So if it's a type error, that means like I did something like I tried to call .map on a number, right? Or I tried to actually JavaScript's really permissive about a lot of operations, so it's hard to think of an example. Or I tried to subtract one string from another. I don't think that works. Does that work? Gives you not a number. Cool. Good job, JavaScript. So yeah, not a number won't throw an error, right? JavaScript will just be like, oh yeah, that didn't work. What do I do next? Yeah, so something that you want to do sometimes is check to see what type an error is. And then if it's an error that you really want to blow up for, you use the throw keyword. And otherwise, maybe you just want to report the error, log it to the console, but you don't need to blow up. You can keep going. You can also use throw you can use throw anywhere. So back in the browser console. And now that's an actual error, right? Like that behaves the same way as though like I actually did something illegal. Here I just created a new error and then JavaScript, oops, And JavaScript reported like this is what your error looks like. Kind of like how if you go, it says this is what your array looks like. When you use the throw keyword, that tells the JavaScript interpreter, okay, start sending this up, and if nothing catches it, blow up. But sometimes we want to be able to influence what type of error it is. So instead of having just a generic error, because that's hard to do anything with, right? It's hard to do this type of checking. Sometimes we want to be specific about what sort of error it is. So we can create custom errors. One way we can do that, actually like the dominant way to do that, is we can create a custom error class that extends error. Now I don't think we've talked about classes at all, right? No? Has anyone ever seen like a JavaScript class before? Yeah? A little bit? Okay. Pretty new. So that's okay. We're going to go over this real quick, but A, you're not supposed to know classes yet, so don't freak out about it. And B, you never do this in application code. If you're writing like a library or framework, you might want to have like some robust, sophisticated error handling solution. But you pretty much never do this in, like, when you're just writing a web app. You let the libraries or frameworks that you're using come up with their own error plans. And then you just like write smart code that tries and catches error as well. So in this case, I have this plan for dressing up a hot dog where I have a list of condiments that are valid to use. And if somebody tries to put on a condiment that does not fit my expectations of what goes on a hot dog, I throw an error. So I can just throw this generic error, as we did over here. But if I want to do like some type checking, like, wait, did they like actually try to like SQL inject my app or something? Or is this like an error in like the data, or did they just try to put like mayonnaise on a hot dog? I might care about that, so I created this invalid condiment error, this like special class of error that it knows how to put the right kind of data in the message, and it also knows what its type is. So instead of throwing a regular error, I can throw my condiment error that I invented myself. Riveting. Good news is that's like all the talking we're going to need to do about errors. Glad that's out of the way. Any questions before we move on to promises? Is this something we don't need to know right now? Is this something we should be aware of but don't need to know? Yeah, pretty much. Pretty much. This doesn't come up that much. You can write perfectly happy, healthy apps without ever doing this stuff. Probably at some point you'll run into a situation where you want to like try catch something, but usually rather than just like letting an error happen and then handling it, you just want to write code that you want to fix the source of the error, not catch the error and keep rolling. Uh, yeah, so Sarah's a few steps ahead, thinking about how does this relate to promises. Yeah, so when you're doing promises, you have like a promise, and then you chain like dot then, and then you have a dot catch, right? Or you should. And what a dot catch does is it's unique in that if the promise doesn't work out, you pass the error along to the dot catch, and that's the way that promises do error handling. So instead of having like try catch, like you would in like we just demonstrated, you would do the catching in another method on the promise chain. Does that answer your question? Yeah, cool. Cool. Um, so we're going to take a little bit of a moment to talk about asynchrony. Um, so we've been talking about asynchronous code for a little while, right? So where does asynchronous code come up? Everywhere. In JavaScript land, it kind of comes up everywhere. Can you be more specific? Yes. Asynchronous code comes up in JavaScript. So it's like a function that you when you want a function to wait until it receives parameters. Kind of like multi-threading, kind of like fake multi-threading. Yeah, yeah, yeah. We're not going to dig into a comparison between how JavaScript does concurrency and how like a multi-threaded language does concurrency, because yikes. But yeah, um, yeah. So asynchrony comes up when you want. So what you were talking about is like deferred function calls. So what was being described? Sorry, what's your name? Sorry, X. Okay. What X was describing was when you have a function that doesn't run until it receives its parameters. That's like an example of asynchrony, uh, which is true. A really common way that asynchrony comes up in JavaScript is you write a function and its execution is deferred until later, right? So for example, in a click handler, right? You have a button on your page and you say, okay, I want you to listen for clicks, right? And the button goes, okay, and it's listening, but while it's listening, you can do other stuff, right? So it has a function that you pass to it in the click handler that's like, I'm going to wait for a click. When I get clicked, I'm going to invoke this function, right? So that's an example of asynchrony. That's an example of deferred execution. The thing that makes it asynchronous is that it's non-blocking. So blocking activities are things that prevent you from doing more stuff, right? So an example I like is like humans are pretty good at asynchrony. Like you can walk and chew gum at the same time, or you can drive and hold a conversation. You can cook and watch TV. Um, so a lot of the things that we do are non-blocking, or at least they're not completely blocking. So if I'm doing something with both of my hands, that means my hands aren't free. So if I'm carrying like a pot of hot soup, that means I can't pick up a knife and chop an onion, right? So in that respect, those two actions are blocking, right? Um, but a lot of things that I do are non-blocking. Um, but if I sneeze, that's completely blocking. Like when you sneeze, you stop everything you do. If you sneeze and you're driving, there are like a few seconds there where you're just like, like what? Um, so yeah, we don't want to write like sneezy code too much in JavaScript, right? We don't want to write code. We don't want to have code that blocks other code from executing. And in some languages, they don't think about that much, right? Like most of Ruby is synchronous. It's blocking. Like one line waits for the preceding line to execute, and you can end up stopping everything to wait for a database query. Um, and then when the database query comes back, the whole application goes like, okay, we can continue, right? JavaScript doesn't really work like that. JavaScript goes, okay, while I'm waiting for that database query to execute, what's next? And this is by design. This has to do a lot with what JavaScript is for, what it was developed for. What was JavaScript developed for? Primitive looking up of documents and stuff. Close. Right ballpark. Any other ideas? What's JavaScript for? What was it made for? Yeah, interaction. Interaction specifically in web pages, right? JavaScript was designed to program browsers and add interactivity to web pages. Today we build like entire applications and user interfaces, right, in JavaScript. And if you think about a about a user interface, you have a lot of stuff going on, right? You have maybe dozens of buttons. You have a little message window that messages are coming into, right? You have like buttons that like they keep track of like a counter. You have all sorts of like different interactions, right? You're making requests to like this API and that API and like a bunch of different endpoints. You have like timers that like you're doing polling, right? So you're sending like an AJAX request out every so often to like check on things. You have WebSockets that might send data back and forth. You have a lot going on a sophisticated web app, right? And all those things need to happen um, sort of at the same time, right? Like it wouldn't make much sense to have like a click handler that stopped your whole application, right? You say like, okay, so my whole app's gonna stop until this button gets clicked. Okay, but now you have like a site with one button. It wouldn't work. So asynchrony is baked into JavaScript because of JavaScript's history as a web programming language. Um, but asynchrony adds a layer of complexity, right? So when you're learning the procedural programming plan, just write the stuff that you want to happen first up here and the stuff that you want to happen next down here, and the code's just going to run line by line. The first time you run into asynchrony, it's kind of a shock. You're like, why is this thing undefined, right? You go like, user username equals Garrett, and then like get user profile makes an API call, and then like on the next line you want to console log out the user object, right? I have a computer right here. I can just type that. So let's say you have right. What do I say? Get user profile. Right. If get user profile is something that exists kind of in my application that I have control of, then there's a good chance that when I console log user object, I'm going to get whatever the return value of this function was. Right? But if this is an API call, what happens? Well, what happens is this function goes and talks to a server. And in web development, the difference between the time it takes for this line to run and this line to run and this line to run versus the time it takes for you to like call out to another server that might be in like some Amazon data center somewhere and come back is it's like years versus hours kind of thing, like in computer terms, right? It takes such a long time for something to go, like it could take like a whole second. Second's a long time. So what JavaScript does is it says, oh, okay, I've made this API call. I'm just waiting around for that. While I'm waiting, I can keep doing stuff, right? So, oh, I have this console log. I can console log user object here. So what does this end up being when we console log it? Undefined? Yeah, good guess. It might be undefined. It depends a little bit on the implementation, right? So like if this function returns promises, then this is going to be like some like promise object, right? status pending. It's gonna be something weird. It's not gonna be that user we asked for. And if we do something silly uh, like that, like wait 10 seconds in console log, you know, maybe your user object, maybe the API request has had enough time to go and come back, and so there's actually something in this object now. Um, and so you go, oh, good, that's all I had to do. Um, and you go like, okay, so now that I have my user object, I can go user object dot right. What this does is not that important, just like some operation that you want to do. Um, and then what happens is instead you find that, oh, user object is still undefined. But wait, I just console logged it up here. What happened? Any ideas? Why doesn't this approach work either? Yeah, so the reason is because set timeout is also asynchronous, right? So in the same way that get user profile, this API call here, um, went off and said like, I'll be back later, you can keep running. That's exactly what set timeout does too. It says, oh, I have to wait 10 seconds, but you keep going. So what we end up with is this line runs immediately. This line starts running. This line starts running. And before either of these things finish, probably, this tries to execute, but user object is still like this weird promise object thing, right? So this approach kind of starts to break down. So how might we fix this without like getting into promises yet? Do we have any ideas about like what we might do to just make this code work? Not even necessarily work well, just make it like work at all. Callback? Callback? Any other votes for callback? Okay, one vote, couple nods. Yeah, okay. Callback where? In the get user profile method. Yeah. Yeah. That's reasonable. So if we put a callback up here, right? Are we comfortable with this like arrow, fat arrow syntax? Is anyone confused by what that is? Okay. So if I keep doing this, like, y'all know that this is like the same as like doing that sort of thing, right? We're good with that? Okay. So yeah, and then what goes in this function? Everything else, yes. Everything that depends, exactly, everything that depends on user object goes in there, right? Yeah, I'm so glad you phrased it that way. Everything that depends on user object goes into this callback, right? Does this make sense? I'm hoping that there's a feeling of I get this right now, that like I'm used to this. I recognize this pattern, right? Because the main hang up that I think people have with promises is you think of it like you're going line by line here. You're like, oh, I need to make an API call, so I'm gonna like go into API land, grab this value, and come back with it, and then get back down like just the straight down the file path. But that's not how it works. How it works is you figure out that you have some code that depends on having the user profile, and then you arrange for it to be synchronized with that dependency, right? So this get user profile thing is probably going to pass like some parameter to this callback function, right? What do we think that parameter might be? User object? Yeah, yeah, exactly. So we would expect that get user profile, instead of returning the user object for us to stick in a variable like this, instead of returning it, it would pass it to this callback function, right? So this is a function definition, so we can call this whatever we want, right? But this function is called get user profile. So we assume that the thing that it passes on when it's done is a user profile, right? Or user object. And then, we hope that this would work. And then maybe we do, I don't know what we do with the friends list, right? But now we expect this to work because inside of get user profile, there's some code that arranges for this callback to not be run until the API call is finished, right? There's one more change that we can make to this code to complete the refactor. Does anybody see it?
Is it just removing the Fox's user object is equal to and calling a method directly?
Exactly. We notice that we aren't like going into async land and then pulling a value out. So we don't need this variable. Right? So the way to think about this is not like I'm going to get something from the API. It's that I'm defining a behavior where I kick off an API request, and then that request is responsible for implementing some behavior that depends on it, right? So getting the hang of asynchrony is all about managing your dependencies. So you notice that to get the names of all of a user's friends, you need a user object. To get a user object, you need to make an API call. So getting the names of all a user's friends is dependent on an API call that returns a user object, right? And that's how we decide what goes in the callback. So everything that has anything to do with everything that has anything to do with something asynchronous falls into this pattern now, right? So you'll notice as you start writing more and more sophisticated code, you stop having things out in the global namespace like this. You stop writing this imperative code, like not strictly, like there's a place for imperative code, right? But you start noticing that more and more of your code is wrapped up in functions, or it's wrapped up in objects, or it's wrapped up in these behavior chains, like this, right? Which you could say is like wrapped up in functions. But you have less and less of your code that's just kind of like floating out here, kind of treading water in the node pool, right? Everything's kind of, I think of it as like everything finds like a boat to ride on. Don't think about that too hard. So now let's imagine that now I want to get for all of these friends. So I can do lookups by username, right? Now I want to get all of the friends for this user. How might I go about that? We have the tools already, right? Assuming I have an array of, I have an array of names. What would I have to do to get all of the user objects for each one of these friends? Let's say I only want the user object for one of the friends, for the first friend. Let's say the friends are sorted by bestness, and I want the profile for this user's best friend. I need to use another callback inside of my callback, exactly. So I would get the first friend by going, best friend is, right? That's Alice. So now I have the name of a best friend. I know I have this user profile, get user profile method function that takes a username and returns a user object, right? So I can go get user profile. And this needs a callback, right? And then now that I have that, I can do kind of whatever I want, right? Um, Maybe that's useful for some reason. Um, so with this callback paradigm, we end up kind of like going like nesting deeper and deeper and deeper. Um, and you have callbacks within callbacks within callbacks, and like that's an okay to do. That's an okay way to do things, especially when it's linear like this, where you have one thing that you want to get, and then with the results from that, there's one other thing that you want to get. You can manage that, and then if this gets if this gets pretty deep, one maxim that we have for callbacks is you're not on callback hell until it goes off the side of the screen, until you're indented all the way out to here. Then you're kind of in the danger zone. But that's also kind of a nightmare, right? Some people say if you're more than 2 indentation levels deep, like you've gone wrong somewhere. Um, but that's basically how it works. So what does this have to do with promises? Promises actually make it a little longer. Um, yeah, so what promises do, we'll talk about after the break. All right. Let's see. Let's do. Oh yeah. Oops.
We have another, well, the guy just turned 30, works in really for blind, so yeah. Go back on
Oh.
yeah.
So I'm not going to save it, but I will turn on the JavaScript grammar. Okay.
Yeah.
All right. Let's get back into it. Talk about promises. Talk about asynchrony. Talk about behavioral dependency chains. All sorts of great stuff in second half. Okay, so I'm gonna tell you a secret that a lot of people kind of like dance around and don't really like let you know. I think everybody who works a lot with asynchronous code eventually comes to realize this uh, on some level, but you never learn it straight up. But I'm gonna tell you. Yeah. Okay. Everybody gather in. um, Promises and callbacks aren't that different. So the reason we talked about callbacks in the first half so much is because like really the logic that you're going through, the thinking that you're doing, well, I want to organize it this way because my behavior has this property, right? That I have thing B depends on thing A. So, and thing A is asynchronous, so I need thing B to be explicitly told to wait for thing A to complete. Like that sort of thinking that you do. It's the same thing for callbacks, and it's the same thing for promises. And in fact, promises use callbacks. It's just a little different. So what I'm going to talk about is a little bit about not so much the practical, the practical, this is why you should straightforwardly always use promises instead of callbacks, but just sort of about the shape of how promises let you organize the problem versus how callbacks do. And it's almost like a little esoteric, a little philosophical and abstract. But then you sort of know what promises are about, and then you can make your own decisions about whether callbacks make more sense to you or whether promises do. So when we do something like what we did over here with user profiles, we have something like right? We have this function, and then when we when we invoke a new function, we're creating like a scope for it, right? And inside of this scope, get user profile is in control of when we call the next callback. So some stuff happens inside of here, and then we call, in our case, get user profile on the best friend, right? And that, of course, creates its own scope. And like, this isn't so bad because it's a very straightforward operation, right? But you can imagine, what if we had to get like the profiles for all the friends? So do we end up with like a bunch of different scopes that we somehow then have to stitch together, or do we end up with like one scope that like inside of that function it stitches everything together? Like it starts to get pretty complicated when this is nonlinear, when there are branches. And it also gets complicated when we start getting really deep, right? So maybe once we get the best friend, we're gonna get like, you know, we're like a panopticon company like Facebook, so we know everything about you. So we got like birthday earlier. We're gonna get your product preferences to make gift recommendations, for example. says get gift recos. And that creates its own scope. And then we get deeper and deeper and deeper. And the more complex these functions are, the more it matters how we're thinking about this, right? So if when we're getting the user profile, if inside this function we create like a bunch of variables, just because of the way function scoping works, these all get carried into this context, right? So it's not just the parameter we pass to the callback, right? It's also all of these variables. They're still in scope. And then, of course, if they're in this scope, then they're also in this scope, right? So every time we nest another layer deeper, we're like bringing everything that we've done before, right? This is like you buy bread, so you have to know about the oven that baked it, and you need to know about the mill that ground it, and you need to know about like the tractor that harvested the wheat, right? It's like you start like at the highest level and then like nest in a way that's very it can get very overwhelming if this goes deep. You have like a lot of like name collisions and stuff, and you're doing a lot of overwriting, right? So if you have like say response or user, you start getting these weird bugs where you're like, oh, I forgot to put user here, so instead I'm using this user, the user that this function received, and like I didn't realize that. Like, why does this work? Why isn't this error at all? Why is this giving me the wrong user? Stuff like that. You get really esoteric bugs that come with just kind of kitchen sinking all of your state into one place. There's another really deadly pitfall that I wanted to mention, but I forgot, so it's probably not important. Oh yeah, I remember what I was gonna say. It's not really a pitfall. It's just kind of a weird thing. That it's sort of weird that get user profile tells this get user profile to run and then tells this gift reco to run. It's like you have a function that receives a callback function, and then that the parent function like has to know, okay, it's time to do this callback thing, as opposed to just kind of like handing off control to another function that then decides what to do, right? It's sort of like, you know, if you're like buying some duct tape to like tape up your shoe or something, you had like a shoe that broke. This is a true story that happened in my life. So you like buy some duct tape on Amazon, and you know, the Amazon delivery guy comes to you and he gives you the package and he says, now fix your shoe. That kind of be weird, right? Like, why do I have to tell Amazon that I'm buying this tape to fix my shoe so that the delivery guy can tell me to fix my shoe, which I was going to do anyway? Like, that's kind of weird, right? That's kind of what you get when you pass like a function as a parameter. You're telling this function to call this function. So when this thing is ready to, it says, okay, now get this next user profile. So these need to know about each other in sort of a weird way that doesn't really matter. It just feels weird philosophically to me. I don't know. So promises aren't really shaped this way, right? Promises are shaped this way. They're shaped in sequence, right? I'm gonna, it says get up. So I just truncated that to get user profiles. It's the same thing. So get up does, I'm just gonna keep it that way. Get up does its thing. Then we do the second get up, and then we get the get gift recommendations thing. Right? So which one of these communicates the which shape communicates better the idea that we want these things to happen in sequence? I'm glad you all pointed here, and if you didn't, I just kind of like projected my own expectations onto you and thought you did. Yeah, this one looks a lot more like these things happen in sequence, right? Like if you're writing like step-by-step instructions for like a recipe or something, and you did it with like, you know, nested bulleted lists or something, so that at the end of the recipe, like everything was indented all the way over here. That'd be really strange, right? More natural would be like you'd have a box that says like, first prepare the dough, then prepare the broth, then make the soup or whatever. You're making dough soup. Um, so this is kind of the shape that promises are. And the difference is this. Instead of get user profile, needing to know about get user profile and calling it, needing to know about get gift recos and then calling it, in each step of a promise chain, you just hand off control. You just say, here's what I got. If you have anything else to do, now's the time to do it. So each step of the promise chain just yields its result. It doesn't call more behavior. It just yields a result. And that's kind of nice because if I wanted to like redraw this, I'd have to like erase a bunch. I'd have to like redraw the circles and things. If I wanted to redraw this, it's like pretty natural to just like, erase this and move it over here without like wrecking the whole diagram. You know what I mean? And it's the same thing is true with like actually using promises is like when they're chained, like in this way, like you just say, here's what I got, do your next thing. It doesn't matter like what the next thing is. It doesn't matter what parameters these functions receive, right? You just pass on the result and keep rolling. So I think promises are shaped nicely. So in both cases, you get this idea that this is dependent on this is dependent on this. But I feel like in the promise pattern, it's clearer that like this is step 1, this is step 2, this is step 3. Any questions about that philosophical tirade?
Sometimes it might be unclear what the like structure of what you're giving the next thing is. Like you're
So
retrieving
distracting.
data from the promise rather than retrieving data from the callback where all the variables are like listed specifically.
Can you come with that question again? I'm not sure I got it.
Um, like for example, in your user profile one,
Switch back from
you
gallery.
can see that you're getting a user object as a parameter into your function. Whereas with the promises, I'm just not too sure how to maybe retrieve that user object.
Okay, so with callbacks, this function receives the user object as a parameter. But with promises, it's unclear how this user object winds up in being available to like this inner function.
Right.
Is that kind of what you're asking?
Yeah.
Okay. Um, yeah, so the pattern here is that for this code to work, for this pattern to work, this callback function and this controller function, it's just like a name I made up, they're not called that, they need to have an agreement. They need to agree on an interface, right? So this callback function expects to receive something, let's call it a user object, right? And expects that object to have a friends list, and there are a bunch of like assumptions baked in there, right? So this function needs to, it's not obvious from this code what this function does, right? So we're hoping, because we're writing things this way, that, well, we're going to get a user object as our first parameter, right? And it's just kind of up to the person who wrote this function whether or not, maybe the first parameter is an error, and then the user object, right? That's like a common problem, like where someone will get, user object will be undefined, and they'll be like, why is it undefined? I'm sure it's defined, like it's in my database, why isn't, the query seems to have worked. And it's just because you didn't get an error, and an error is the first parameter, right? So this callback function and the caller function need to agree on what the parameters are. Promises work a little bit differently. It's actually a really good segue into talking about how promises work, so thank you. So promises work a little bit differently. As some of you know, if this was implemented with promises, you'd get something like this. Not the string username, that's silly. That's where it starts, okay? this function is going to return what in a promise implementation? It's going to return a promise, yeah. Um, so if we go, what's that for? We're going to see that we're going to log out like promise status pending or something like that to the console, right? So this returns a promise. When a function returns something, we can call methods on it as though it was like the value itself, right? So if we have like we have a function like this, and all this function does is just return this object, right? We can use this function. We can call .friend list on the return value of this function and just use the function as though it was the thing it returns, right? Does that make sense? Is this a shock to anybody? Or is it confusing at all what this does? So this is pretty common. You do it a lot in jQuery, right? So like, right? So whatever this function returns, right? This is a function. You can call .append on that. And you know that because jQuery enforces that. So just like this function returns an object, this function returns a promise. So that means you can call methods on the promise. What's an example of a method that we can call on a promise? Yeah. Exactly. So this first thing returns a promise, and then we can start calling methods on it. Same way as like when you do when you have like a jQuery object, right? You can go like you can start chaining stuff, right? Same thing with promises. You get back a promise from this, you can start chaining .thens. So what goes in here? Basically a callback function. The difference between doing a callback this way and doing it this way is that the interface here is enforced. So like this callback function could receive like any parameters, right? It's up to this function to decide what it passes to the callback, right? When you do a .then, there's only one thing that can be in there. It's the result of when this promise resolves, it passes on a result. That's your parameter, right? And that's always the case. So we get the result, and if we were to console log result here, we would get probably a user object, right? So we might call that user object to make our code a little more readable. So then, oops. So what are we doing in here? If we were going to mirror the behavior up here, right? What do we do in here? Okay, so the question was, what makes get user profile return a promise? Is it something that that we define where like somehow we configure it to return a promise, or is it just something that like happens? It's a good question. I guess one answer to that question is this could just be a wrapper around something else that returns a promise. So for example, if we were to look at how get user profile is implemented, it might look something like this. Right, so we have a function, and then what this is going to do is, we familiar with the fetch API? No? Okay. Fetch is just a way to make HTTP requests. It's native in your browser. It's real good. It's going to be, can't do it that way. Right, so if you imagine this kind of route existing in your app, right? Actually, I'm not gonna. There's some extra boilerplate that you have to do with fetch, but let's just pretend. Let's just not worry about that for now. You do something like this, right? So fetch uses promises, right? So when you do fetch, the fetch implementation returns a promise. Therefore, this function returns a promise, right? So you might have like a bunch of config options. It's like your HTTP headers and stuff. And then at the end, you just invoke this thing that returns a promise, right? Kind of like how it could be. Oops. Like it could be like a connects thing, and that's going to return a promise. And then on here, you can just start calling like .then. The other way to think about it is you could be implementing promises yourself. So if you did that, you can just new up a promise like this. This is kind of jumping into, this is like a little bit of a course shift to, this is like how promises work on the inside. So this is how the people who wrote the connects library would have been managing their asynchronous stuff. So when you create a new promise, it receives a callback function that always receives two parameters. It receives resolve and reject. Okay? So how it works is that this callback, instead of returning something, it either calls resolve or it calls reject, right? So there's nothing asynchronous in here. Promises don't need to be asynchronous, but if they're not, then it's kind of weird that you're using them. It's just like extra code. But they by no means have to. This is like all that a promise has to be, right? So as soon as resolve is called, the promise state changes from pending to resolved. And what do you think a promise does when its state changes to resolved? You hear a guess over there? No? Okay. What do you suppose happens when a promise resolves? It triggers the then. Yeah, exactly. So if you resolve, then you're hoping that there's a dot then on the other end for you to pass that value to. And I guess the promise doesn't really care. Like if it doesn't have a dot then, it probably just gets on with its day. But yeah, when you call resolve, it triggers the dot then.
So in the case of what you just built there, it would pass on the resolve value.
Exactly. So in this case, when we use this, get user profile. And we're actually not even using the username, so oops. Exactly. So when resolve is called, dot then is triggered, and what do we expect to receive here? Yeah, exactly. We're going to receive the parameter that resolve received inside the promise. So if this pattern is like a little weird to you, don't worry. You hardly, pretty much the only time that I can really see um, y'all needing to like write your own promises like this is if you have some library that like doesn't use promises and you want to treat it like it does. Um, you might just write a wrapper that like makes it promise oriented. But in general, the way that you use promises most of the time is this way. You have like some function that just does the thing, or you have a function that's a wrapper around some function that just does the thing. And then, this returns a promise, so now you're in promise land. Right? So it starts, when you use promises in your web applications, it usually starts with somebody else's code, which returns a promise. And that's how you get into promise mode. Does that make sense? Cool. So yeah, over here we're going to get the result of what resolve received as a parameter. If I go dot catch, what goes in here? What are we going to see here? Um, so you'd only see this if there was an error. Not exactly. This error is going to be whatever. Well, if there actually is an error, then yeah, the error will be passed along to catch. But also, if reject is called for any reason, this parameter gets passed along. So in this case, let's do that. So now this promise is going to reject instead of resolve. That means it's going to go down this path. So error is going to be the parameter that reject received. Now we might make that like an actual error, right? In which case, maybe instead of console logging here, what do we want to do instead if it's an error? Throw it, yeah. Yeah, so maybe the thing that we want to do is like our way of catching the error is to throw the error and raise it to the rest of the application, right? So yeah, that's kind of how promises work on the inside and sort of a roundabout way of answering your question. Does that help with that? Cool, 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 cool. Let's get that down out of the way. So yeah, interestingly, when we go up here, what we wanted to do was like get all the friends and then get the user profiles for those friends, right? Or no, sorry, get the user profile for just the best friend. So we can, to turn this from like callback mode into promise mode, we can just do like a lot of copy pasting, right? Actually, we can copy paste like most of this. So now this is kind of interesting. Oops. What's the value? What's the return value here going to be? What's this going to evaluate to? This part. Another promise. Exactly. So if this returns a promise, right? Then we know that we can just chain another dot then, right? And what's the result here going to be? Yeah, the user profile for the best friend. Yeah, exactly. Um, so we just name it that. Just like up here, we can just name this whatever we want. Um, so interestingly, let's say we wanted to pass this along, right? Um, so now I've got the best friend object. We got the birthday out of that. Um, what do you expect this to evaluate to? So up here, the return value evaluated to a promise, right? Pardon? Yes, you can. Let's take a step back. What would you expect? Like, this is just an object that has like a bunch of attributes for the user. Like, maybe you have like a birthday column in your database, right? So what do we expect the return value here to be? What do we expect this to be? Like data type. String? Yeah. String. Maybe a data object, but string's a good guess, especially if it's like fresh from the database. Yeah, maybe this is a string. It's not a promise, right? Can you call dot then on a string? Can't do it. Strings don't have a dot then. Um, but to totally contradict what I just said, you can still do like you can still do that. You can keep chaining dot then dot then dot then dot then. The reason is because even though this is a string, the thing that dot then returns is always a promise, even if like the value itself is not a promise, right? So we do dot then here. We just pass the value along. And that's cool because now we don't have to think about asynchrony, right? We can just like break up our steps, like step by step. Like we can have a function that's like return, right? And this is just some math. It's not asynchronous at all. Oh, we don't need return there.
Sorry, Calgary has a question.
What's up, Calgary?
Promises are asynchronous. How is best friend a promise? The promise is asynchronous, but it's
Um, yeah, promises are asynchronous. The stuff that happens inside of the promise doesn't have to be asynchronous. So for example, this function um, this function isn't necessarily asynchronous. We're just doing some math, right?
So the promise itself is like the result of the of what you called. So that and like I'm just trying to like figure out exactly what the promise is. So the promise is the result.
The promise is the promise the result.
Like so
The promise is eventually a result. So I'm trying to explain this without using the word meta value.
but when you say like then user object or return the user profile best friend return the promise and then you call then best friend object so then returning promise which is the result of best get user profile best friend. So isn't that the result? Get user promise. Then you call then on the result of best promise.
uh,
Does that make sense?
yeah, so we're kind of talking about how do like promises and non-promises kind of behave next to each other, like in this promise chain.
Kind of.
Is that kind of what we're talking about?
Exactly what
Okay. So
that work, but to the concept of just the promise, like to me the result is the promise.
yeah, so let's walk through that a little bit. The way it's going to work is get user profile is going to return a promise, right? It's an API call, right? So something inside of here starts the API request, and then while that API request is working, the return value of this is going to be a promise, and its status is going to be pending. When it resolves, now you have a value, right? So before it's just kind of like a placeholder for a value. It's like, I promise this will be a value eventually, even if it's an error. Once it becomes a value, like in other words, once the API call comes back, then we pass the value along, right? So in this case, we find the best friend and then make another API call. So it's like this placeholder value again, right? That's what the promise is. It's like a meta value that like doesn't have like a real value yet. So the API call goes off and like does its thing, comes back. Once it's a value, once the promise resolves, yeah, then it's like actually it's actually like a user object instead of just like a promise to go get a user object, right? And then in this case, so then we pass it down to that next dot then. In this case, this thing is already a value, right? So the way that it works when it's inside of a dot then is that the dot then is going to return basically like a promise that resolves immediately, right? Which is why we can chain dot then on it.
I get it now.
Okay, cool.
Yeah.
But the fact that dot then like always returns a promise is also the reason that we can't just go like that. Oops. Right? Dot then always returns a promise. That's because when we go into promise land, everything that we want to happen that depends on the stuff before it has to happen inside of the promise chain. So we can't like go in and then like, oh, we don't have to return there. And then like return this and then put that into there, right? We can't do that. Because this is going to be a promise. We're just going to get like promise status pending. So yeah.
That's true.
What's up?
That's true even in your custom promise example as well, right?
What's true in my custom promise example?
That it'll return a promise when it does the resolve stuff.
Oh, yes. Yeah, for sure. So even in the custom promise down here, basically once we start this promise chain, everything that comes out of this chain is a promise, right? Which is why we can chain dot then, dot then, dot then, dot then. Even if at any particular step in the promise, we're not actually like returning a promise from that particular callback function. We can still treat it as though it is a promise. It's like a promise that resolves immediately. Does that make sense? Cool. Few more cool features before I let you go. To make promises like really like far and away better than callbacks for this is like we had how to get the birthday out?
Yeah.
What do you mean?
Like you said, you can't just do birthday equals.
How's best friend?
Birthday, return best friend object dot birthday.
Mm-hmm. Yeah, yeah. So I think you might be asking the same thing. So I'll talk about that question. How is best friend a promise? So best friend is. So are we talking about is? Oops. Are we talking about this best friend? I might have misunderstood what you meant by best friend. This best friend is not a promise. It's just a parameter that you pass to this function. So best friend is probably going to be a string. So if this is the array we have, best friend is just going to be Alice. So we're not returning best friend at any point. Best friend is just a parameter that we give to this function. Does that help? Okay, so the reason you can dot then is because get user profile does return a promise. But that said, just to drive the point home, even if you did just return the name here, because best friend is part of a dot then chain, this return value is going to be a promise, which means you can dot then. So instead of receiving the result of that second API call, we'd receive just that plain string. But even though it's a plain string, we treat it like a promise. Does that help?
So now in our main like document, how do we get out that best friend object dot birthday that you're returning below, so that we can manipulate it normally in like at clock speed instead of
Ah. Okay, so if you wanted to get this birthday out so you can just kind of like go back to your procedural programming plan,
yeah.
how do you get it out? Um, well, I want you to strongly consider that you don't. So that's not strictly true, and I'll explain what you can do instead later. But if you're thinking, okay, now how do I get this value out? Um, that might be the wrong way to think about it. Pardon me? Yeah, yeah. How can I get out of the like? I want to stop doing promises. I want to go back to just coding line by line, right? Um, the answer is that that's like kind of the wrong way to think about it, probably. The way that I want you to think about it is that whatever work you want to do on the web page, whether that's like you make an API call and in the dot then you publish a new tweet, right? For example, I want you to think of it in terms of like whatever you're going to do with this data, you do inside the promise chain. So I'm going to write it to the database. Okay, do the database right in the dot then. I'm going to publish a new thing on the page, a new div with some content in it on the page. Okay, do that inside of the dot then. That's the pattern you want to go for. And if you violate that too much, if you try to do it in terms of like, okay, I got the value I want in here, now I need to pull it out and bring it back into like imperative land, you're going to cause yourself a lot of trouble because you're violating that property that promises have, where this thing, I guess you start at the bottom, this thing depends on this thing, depends on this thing, depends on this thing. Right? So each step up the chain, you're like enforcing the dependencies between all of the dot thens. And then when you break that, you're kind of opening yourself up to hit strange bugs. So generally, that's the whole like paradigm shift that you need. Is that when you start doing stuff in promise land, you finish what you're doing inside the promise chain. Now, let's say you're like, okay, cool, but I'm not going to do that. Then that's not so bad. You go out in this scope, you go let birthday. Oh, that's not going to work because those are named the same thing. Right, and then down here, if you're lucky, this is probably going to be undefined if you run it just like this, but like if you do like enough, muscling of like the timing here, you can maybe force this to contain this value. Right?
I feel like if we use var, then maybe it would work, but
If you used var.
instead of let, then it's more open.
Oh, it doesn't really matter if you use let or var. So there's like some scoping differences between let and var, but those don't apply here. So this is just a matter of let exists outside of the promise, so you can still access it outside of the promise. Like this best friend object, for example, it only exists like inside of here, right? It's only scoped to that callback function. This variable is going to be available outside of the promise chain. So if you do stuff to it, then those values are going to be reflected there. But again, it's like the asynchronous part, right? It's the timing part that is hard to get right. And the right way to get that timing right is to do it, do anything that you want to do with this value inside the promise chain instead of trying to do it out here. Does that make sense? Cool. So we're like basically out of time, but I want to talk about a few cool features of promises that might become useful very soon for you. The first one is promise.all. So what promise.all receives is an array of promises, right? So you use promise.all when you have multiple dependencies. Let me go back to the board for a sec. So like when we were doing this, we had this situation. We had this situation where we have like many users, and we just grabbed the first one, right? And there was sort of this problem that we hand waved, like, well, what if we wanted to get all the user profiles? We had to make like several API calls. With callbacks, there's not really a good way to like make 2 callbacks inside of like one function and make them line up properly, because if you imagine you're going to get gift recos for all of the friends, you kind of have to create like all these like diverging branches that completely lose track of each other, right? What promise all does is like when you have multiple promises, so it's like I need this user profile and this user profile and this user profile. Promise.all lets you connect them all to like the same the same .then. So when you use promise.all only resolves when all of these promises resolve. Does that make sense? And then we also have promise.race. Promise.race is kind of the same idea. It's like you have many different promises that are all running at the same time. The .then doesn't run until one of the promises resolves. So if you imagine, let's say you have an app that like reports like what temperature it is outside. And you have a couple different APIs you use, and like sometimes they work, sometimes they don't. What you do is you have many different calls to several different weather APIs. The first one to answer, you just go with that one. Right? So promise.all is they all have to resolve and pass the value along. Promise.race is only one of them has to resolve and pass the value along. I think that's all the time we have to talk about that, but yeah, if you're stuck on like a promise-all, promise-race situation, feel free to grab me after. I'm here all day. Any questions before we wrap up? Okay, anything from Calgary? Okay. All right, that's it. Thanks, guys.